what is up guys? Welcome back to another video on code dev. In today's video, I'm gonna be teaching you how to make a Python code to solve Newton Raphson method. I have already made the code and I'm gonna be explaining you the code so that you can make it yourself. So it is like a challenge for you to make it. Consider it as a task. If you learn how to make this yourself, your programming skills will get really good, like real good. So let's start with the practical demonstration. Let's start with the code what I have here. So here we have the code. Uh, First of all, we have what we're gonna do. What you're gonna need in this code is uh, a function, an equation, and its derivative. And then what you're gonna do is you're gonna need is maximum number of steps and the amount of error which you're gonna tolerate. Like if your if the error you're getting is gets lower than 10%, then you're gonna stop. Then your condition will get false and you're gonna stop solving this method. So what we're gonna do is first of all we have a function here f of x which is taking the equation which is x cubed minus 5x minus 9. Then we have a function g of x which is returning the derivative of this equation we have here. Now we have a function here Newton-Raphson method which is taking three things as input: x naught, e, and n. Here x naught is our first guess. Now what is first guess? Like in the practical demonstration which I showed you, we actually calculated the midpoint of the two values where our sign was interchanging. But when you're solving it on a code, what you're gonna do is you cannot find a midpoint. So you're gonna give the initial guess where you think the sign will change. Now E is the tolerable error and N is the maximum number of steps. Now we have created a variable here that is step equals 1 and flag equals 1 and condition which is equals to true. While condition is at its value, what you're gonna do if the derivative is equals to 0, then what we're gonna print divide by 0 error, because the formula I told you, it was x2 is equals to x1 minus f of x1 upon derivative of f of x1. So if our derivative is going to be 0, so it will be divided by 0 error and we will not be able to solve the equation. Now what we're going to do is, this is our formula, x1 equals to x naught minus f of x naught upon derivative of f of x naught. Now we're printing here that this is our step 1 iteration at x1 is equals to, here our value will come, that is x1, and then here at f of x1 our f of x1 values will come. Now x naught, in here we are after each iteration here we are appending the value. Now our x1 here will become x naught and the value which is yet to come will become x1. Now after each iteration we're going to append the step, we're going to increment the step. So after appending the value, what we're doing is we are incrementing step after each iteration. So whenever the step on which we are at gets are bigger, then the maximum number of iterations we have to perform, it will turn the flag 0, which will break our condition and it will come out of the loop. But if flag is equals to 1 and our and it will break the loop here. Now we're saying that condition is equals to absolute f of x1. Now what does absolute does? It does not matter if your f of x1 is negative or positive. Whenever it becomes greater than the tolerable error, what you're gonna do, you're gonna change the value of the condition. As soon as you change the value of the condition, it will get the while loop's condition will become false and it will get out of the while loop. Now if flag is equals to 1, it will print that the current value of the f of x1 is our root. And if nothing from all of these equations does not happens, what it's gonna do is gonna say not convergent. It means you cannot solve this. And now this is our input section. Here we are taking input x naught, e, and n. And then here we are converting x naught, which was our first value, into float, because your first value can be an integer or it could be in a decimal too. And tolerable error in float too, because percentage is always in float. And the number of steps, maximum steps, we are converting it into n, because you can never perform 2.5 steps or 3.19 steps. So we'll convert it into integer. Now, here we call the function. Now I'm gonna run this code once. See, it asks us to enter guess here. Let's say our guess is 2, and our tolerable error is 90, and maximum number of steps are 6. So, it performed one iteration, and at that one iteration, our tolerable error was greater, so it just stopped at 1. Let's run it again. Let's say our guess is 2. Tolerable error is 0. Maximum step 6. So it performed 6 iterations, and it told us that it is not convergent as f of x1 at 2 of the steps became 0. Well, let's run it once again, and let's say our initial guess is 1, tolerable error 0, maximum step 4. So it performed 4 iterations, and it said not convergent because we cannot get any value of it.